Now we move on to continuous data. So contrary to the discrete data, continuous data is the quantitative data that can take or accommodate any value, not limited to exact values. So it can be approximate, it can be specially approximated values. You're going to see that that's when we introduce ranges and what we call upper bounds and lower bounds, and then we have a range of values. You're going to see that later on, and that's when the values are not exact or fixed. And then we have other points. We say continuous data is not limited to exact values or particular events, as aforementioned. This information can show trends in data over a period of time. That's basically continuous, because with time you're going to see that things change. They're not fixed. Events won't be fixed. They will be changing as time moves on. So it's good to call that continuous data. And other examples are length. You can take ranges of length, or maybe height of people. Many examples of people's height, or maybe shoe sizes. Many people have different shoe sizes. Yes, and all the like. Basically, there have to be some continuous or continuity of the values, or approximation of some sort, as with an example that we're going to look at very soon. Okay, so the example says the traffic police department, hypothetical one, identified a new high accident zone. So they sent some traffic officers to check the speed of each car that passes through the zone, and they had to do this in half an hour, and then send the data to the department officers for analysis. The following was the raw data in kilometers per hour for 20 cars. So it was just in one 30-minute session. Those are the speeds. Using the information provided, state the type of data. As you know, that is going to be continuous raw data, as you can see. And then on the second question, it says, what is the modal speed and the median? So we're going to look at that, and we draw the tally chart according to C, with the columns for speed, tally, and frequency. And then you represent the data by drawing a histogram. So let's get on with that. Okay, so the first question we already answered it. This data is called continuous raw data. Because we can see even the speeds, we are only seeing one value for each speed for each car. But the fact is, those cars were not moving at that speed exactly. They were moving in a range of speeds, but we had to take one value. So when they were taking with their radar or their speed tracker, whatever they were using just to track the speed, they just took one value, and that's the one they sent to the department's office. So those are the speeds that we saw. And then the B part says the modal speed is 125 kilometers per hour. So you see how many 125s are there, how many hundreds are there, how many 80s are there, if there are any 80 kilometers per hour. Since it's a high accident zone, we're expecting that there are more cars that are moving above 80 kilometers per hour or beyond 100. So moving at very fast speeds, basically. That's why we're suspecting that's why we have many accidents, because of those high speeds that we are seeing in that rectangle. So according to our data, 125 kilometers per hour occurs twice in that collection of data, and that means that becomes the mode, because all the other speeds are occurring once. It's the only one that's occurring more than once. And then the mean speed is approximately 149 kilometers per hour, correct to three significant figures. The mean is found by adding all those speeds that you saw, and then you divide by the number of occurrences. So here we have our number of occurrences, which is 20. We have 20 different cars that we recorded their speeds, and then we divide that into the total number of speeds. If we add all the speeds together and then we divide by 20, we then get that 149 kilometers per hour. So with the tally, we just use that way of counting. With the tally, is just use the strokes, and then you are good to go. It's an easy way of writing than using the Roman, not Roman numerals, the Arabic numerals. They might take you time to list everything, but if you just take those strokes, you might be able to do it fast. So the frequency now, you then do it after you're done taking off all those values, and then you write down the actual figures in Arabic numerals, which are 2, 4, 6, 5, 2, as you can see, and then you draw your histogram. with the speeds on the horizontal axis and the frequency on the vertical axis. I think we already know how to do that histogram. As I said, you use the values that are in the table, and then you put your scale. You decide, is it from 0 to 10 or 0 to 5 or 0 to 100 or 0 to 20, or you can even start in the middle. You can start with 5, not even from 0. Start with 5, 5, 10, 15, 20. You can decide the scale. You can decide how you want it to look, and then you just plot your histogram accordingly, according to your scale, and then you analyze the appearance of the histogram and what it's showing you. You can even comment on the skewness. Like with this one, it is positively skewed, so it's towards the negative side of the number line, but it will be positively skewed. The skewness is different from the direction of the number line, so that's something that you might be required to comment on, the skewness. And with the previous example that you looked at, the previous histogram in the line graph, in the discrete example, we see that one it's negatively skewed. It's more to the right, more to the positive side of the number line, so it's negatively skewed. Then the other thing that I want you to take note of is the speed column. We put the units, it's kilometers per hour. Then also we put the ranges. We don't put each and every number or each and every speed, because look at the speeds, they are big values and they are a lot. 20 is a lot. You don't want to write all 20 speeds in that column, so just put ranges. When you have a lot of data to group, you have to put it in ranges so that you don't deal with a lot of data, because what you want is to then represent that data on a graph or on a pie chart or on a box and whisker plot or whatever. You want to then represent that data, and you don't want a lot of numbers to deal with. You just want ranges so that you can see the shape of the graph. You're not concerned about the exact values or the continuous values or how the raw numbers are, but you're concerned about the trend in those values, and you are concerned about how they are distributed. We're going to look at distribution of data and of probability and all that later on in our next episodes, our future episodes. Probably it will be one of our last episodes, I am assuming, on distributions. We have normal, geometric, binomial, Poisson, many types of distributions that we can use, and approximations of the distribution. We're going to look at all of that, but you don't want to look at all those distributions with each and every data applied on those distributions. You just want to look at how they are looking, how it is looking like, how the data is looking like, not focusing on each and every value, because that takes a long time and it's very unnecessary. If you summarize it, you're basically doing a lot of favor, and you won't have to deal with a bigger scale on your graphs, and you deal with a smaller scale and still come up with the graph and with the conclusion that you want to come up with concerning your interpretation of the data.